How's everyone today? I feel good. That food was pretty delicious. It was on point, at least. Do I press play? All right, so I'm Richard. I'm the CEO of 4K.com. We have a booth out there. Come by, check it out. Got some shiny objects for everyone to check out. And what we're essentially building, I think, is one of the key things that need to be built in crypto, which is building a digital to physical bridge, and basically bringing physical assets on chain. Now, this problem has been talked about for ages, early as 2014, 2013, colored coins and whatnot, but no one's really found a really great solution. So what is 4K? 4K to us is really three core components. The first being the protocol. So the protocol is the underlying blockchain, the smart contract, exchange, and architecture powering this ecosystem. The second part is the 4K marketplace, or AKA the platform. And this is where users are able to interact with the protocol. They can buy, sell, trade, whatnot, and work with it. The third part is the service layer. So what I mean by service layers, this is necessary to be able to bring these assets on chain. Think of it as a physical validator, or some people run validator companies in here. It's a blockchain validator, but we are a physical validator. So that is authentication, insurance, storage, and logistics. And all of these things are really necessary to really do this. And so probably people are wondering, what type of assets are we doing? We're not doing some boomer real estate, okay? So like, who under 4 years old can say, hey, I'm a sophisticated real estate investor? Not many of us. The millennial dream these days is to not have a roommate, right? But what do we really know growing up? We know Pokemon cards, we know sneakers, we know watches, etc. Stuff that we're interested in. So these are the type of assets that we're really focused on. These are investment-grade assets that are not consumable assets like a USB cable. These are assets that you want to hold for longer term, that have some financial value, and they tend to go up over long periods of time. Eventually, we can do wine and even cars. I think cars would be fantastic. Imagine being the largest Ferrari owner in the world, 200 Ferraris, without actually storing or holding any physical Ferraris, and how to deal with maintenance, storage, and all of that. And so we look at this, right? Like, what's the problem? It looks fine to me. So what does the current marketplace kind of look like, right? We have eBay, Gen 1 internet, StockX, Chrono24, arguably Gen 2 internet, and they charge a ton of fees, 11, 15%. The internet was supposed to be the great equalizer. At the same time, these fees are never decreasing. PayPal has never decreased their fees since arguably its founding day. These guys are constantly increasing their fees. Sotheby's and Christie's takes 40%, if you guys are not aware of this, 25% on the buy side, 15% on the sell side, plus sales tax. So when we do the math, if you buy an item and you sell an item on eBay, you have to make 23% margin to break even. And to me, that is a tax on the working class. That's what it is. It's a global tax against the working class. It's obscene. These are database operations at these days, right? They can, it's crazy. Second part is logistics, settlements, and access. So if anybody has ever purchased anything off of StockX, you'll understand what I mean. It takes up to 30 days to get your item. It's kind of ridiculous. In the day of Amazon overnight, I have to wait 30 calendar days to receive my item. And so, well, how does it work? I think it's really simple. User sends us a whitelisted item to 4K like a Rolex. We authenticate it, insure it, store it in our facilities, and then we issue user the NFT, completely permissionless. And so with that NFT, the users can do whatever you guys want with it. You can collateralize, get a loan against it. You can sell it on our marketplace. You can sell it on any other marketplace. You can sell it to your friends. And when you want the physical asset, you send us the NFT, we burn it, and then we ship you the physical underlying. It's a really simple model. It's nothing like absolute crazy, isn't crazy mechanisms. It's really simple. And so what is the benefit of this solution? I say just cover the highlights. Number one, 1% fee. Compare that to existing platforms like Sotheby's and Christie's. It's crushing. And that's a 90+% reduction in fees relative to legacy Web 2 platforms. The buyer, great for buyers. You guys only just pay gas fees, permissionless. And we're trying to really focus on decreasing the cost of authentication, storage, insurance, and with some really innovative mechanisms designed there to do so. And the last part I think that just gets everyone excited in this room, as all crypto nerds like I am, is the integration with DeFi. I think that's absolutely key, right? We can just balloon up this ecosystem. These are all unleveraged, unproductive assets that sit in people's homes that can't really be put to work, and now you can put this to work. For sellers, it's fantastic if you're a seller of these assets. No chargebacks and disputes, and instant settlement. Isn't that the dream? PayPal is no longer withholding your cash and making money off the float like they usually do. No delivery issues. You're shipping to a company by pallet. You're not shipping to 500 customers dealing with shipping problems and receivable problems. Not worrying about storage, security, and clearance. And lastly, for buyers, no waiting 30 days. I'm a celebrity. I want some Yeezys. Why am I waiting 25, 30 days to receive them? You get professional customer service versus like some eBay seller that responds to you 36 hours later and says, what's up? That's it. and many other items. And so I say, why is this awesome for the crypto ecosystem? Again, interaction with DeFi. I think it would be fantastic. Collateralization and borrowing against it. There's many other protocols out there that does this, to do this. Fractionalization, yield farming, liquidity pools, AMMs, insurance, derivatives, ETFs opens up the entire financial primitives to these type of physical assets that otherwise do not exist. Metaverse gaming, VR Tinder launches. I walk around with a Rolex and VR Tinder. Got to have the NFT, which means I have enough money for the physical asset. And then you can also, last part is, I think Maker just talked about this, is actually using this as collateral for like a MakerDAO CDP, where it's, percentage of the CDPs are backed by the physical assets. In the traditional system, you'll be able to earn yield and borrow against unproductive and leveraged capital. I have $1 million worth of Rolexes. How do I get a loan against that today? I go to a pawn shop and get wrecked, for lack of a better word. Abstracts away a lot of complexity, instant and reversible transactions, and you're able to capture arbitrage across all the markets. So some of these assets you guys are aware sell for significantly more in Dubai and China, but you're not able to capture in the markets because you have to abide by KYC AML laws. And you can buy and sell with confidence and speed. That's key here. So when you try to buy these assets on secondary, one of the biggest problems that people come to us with is it real authentication? And I think in America, in the United States, the level of authentication is a very low bar relative to what else is in the rest of the world. So we're going to build the really standard of authentication and transparency to build a system. And we're going to have really, really innovative mechanisms to do so. And I think this is going to be absolutely key to build that trust to be able to bring these assets on chain. So the future, kind of like it or not, kind of a meme. What we're going to be building, essentially, quickly, is just it's a global physical validator and storage network. So we're just starting with the United States. We're going to quickly expand to overseas. We're going to have something called physical product yield farming. I think some of you in this room may understand what that is, but I think it's going to be wild. We have something called provably fair drops, which we'll cover slightly in a little bit. We're going to have physical asset pricing oracles, insurance pools, interoperability, provenance, DAOs. I think what the goal of 4K is progressive decentralization. So it's going to be a network owned by the users. And so how we do that is through DAOs. We have curation DAO, we have economics DAO, enforcement DAO, and all of these types of DAOs. And the last part, why don't we have AMMs for some of these products? Why isn't there a PlayStation 5 USDC Uniswap pool? Wasn't that a lot better experience than eBay? Right? You just go there, boom, boom, done. You can speculate or buy or sell like that, and it's fungible, and you get high quality products. And I think exploring crazier ideas, like what if we took a real life racing horse, NFT'd it, and then brought him into Zedrun and started breeding him and racing them for people in this room that understand what Zedrun is, right? And the last part is kind of metaverse, applications. There's going to be a lot of those in the next, I think, 5 years or so. Flexing in the metaverse, showing up your house. You have all this art, but you have to have the NFT for it, so it's a real life art. And what I'm saying is that this ramp between the physical and digital world has to exist for all of these applications to really be possible. Otherwise, you're just dealing with digital goods, right? And so I think it's really interesting. One thing that we're starting out on, I think, for more crypto companies in this audience, is something we call initial merchandise offering. So other people that don't understand this is something called Uniswap. So Uniswap launched these socks called Unisocks. If you're looking them up, they're probably $100,000 a pair today. They peaked at $160,000 a pair. There's 500 tokens for them, and you can redeem these tokens for a single pair of socks. They're put on a bonding curve, and I think it was absolutely crazy, but it was a way to build the engagement in your communities. I think this is key. If I made a bunch of money off of one of these crypto projects, why wouldn't I buy a really nice shirt that maybe costs few $100s or a few $1,000s to support them? I think it'd be very interesting. And with 4K, we're allowed to do that because what you need is somebody to be the ultimate authority to say, hey, they only have 1,000 t-shirts. That's it. So currently, what we're having on our site right now, and I think I encourage people in this room to enter, is we're dropping a Rolex Submariner Black, a date, if you guys are into watches. We're dropping at MSRP, $9,150, and it retails for around, it sells on secondary around $14,000, $15,000. And so it's a pretty good profit if you win. But what we're doing with this is building transparency into how these companies do drops. So one of the biggest problems with drops, with what Nike and all these guys does, is dominated by botters and getting it backdoored. So they give it to their friends, or there's massive bots. I know how to know these bots. I bought them all. I have 32 bots. And so it's really easy to enter. So you must have an Ethereum address with the dollar amount in it already. We call it proof of capital. So if it's 9,100, you must have $9,100 worth of USDC or DAI in your wallet. And so what that does is that prevents Sybil attacks. Having 100,000 accounts becomes very difficult, as opposed to, so you can't have 500,000 accounts. The cost of capital would be astronomically high. Enter your email, so if you do win, we can actually reach you. That has been a problem. And so I think this key is going to be absolutely key into how companies and brands will eventually launch products. We're going to have a really interesting beta coming up. So it'll be a marketplace where you can buy, sell, similar to something like OpenSea, where it's really focused on physical assets. But again, just want to just reiterate the point that this bridge is so important to bring on a total new asset class that's been completely under-leveraged, underutilized, that's owned by retail to bring into crypto. And when you unlock all of this value, look at all the diamonds that are stored in vaults, all the cars that are stored in facilities, all the sneakers. You have probably friends in this room that store sneakers to the room, to the height of the ceiling in their living rooms. You have watches. You're able to unlock all this unproductive and unleveraged capital and bring it into this ecosystem. Why isn't there an ETF of Rolex? Why isn't there ETF Ferrari? Why isn't there ETF of Pokemon cards? Why is it so difficult to buy these things? And if you do buy them, you're afraid of getting faked and scammed or whatever. I was trying to buy Pokemon, Shadowless First Edition Charizard. Super hard. I don't know if you guys ever tried to buy one. This is actually really nerve-wracking for me to buy. I don't know if I'm getting ripped off. I don't know if it's real. I don't know who the seller is. There's no the authentication is they grade it says PSA. That's it. So I think this type of solution offers so much to the entire ecosystem, and we're able to bring significant value to everybody involved. That's it. Thank you.
Thanks so much, Richard. And next up, we have Alex from Aleo.
Oh, nice. Oh, there's even a timer. That's helpful. Hey, everybody. You guys let me know when you're ready and I can get started. Hope everyone's having a good day, and great to see everyone. Okay, so hey, I'm Alex. Here to talk to you today about Aleo. So yeah, Aleo is a new layer 1 blockchain focused on using zero-knowledge proofs to deliver the next generation platform for private applications. So this is what it is in a little bit more detail. So like I said, it's layer 1. And the model here is a little bit different than a traditional blockchain, something like Ethereum where you have this on-chain execution model. So Aleo actually uses a model called Zexi, which is some research by our founder, to do off-chain compute, on-chain basically verification. And so yeah, it's an end-to-end platform here. So what we built is an end-to-end platform of which a blockchain is a part. So that's Snark OS kind of at the bottom of the stack there. Snark VM is the execution model where as I said, clients effectively compute proofs off-chain, submit them on-chain as transactions, similar to Zcash. Leo is the programming language and compiler that I'm actually going to demo today. I'm going to demo a program that I wrote in Leo. And that's basically all about writing high-level logic that compiles down to zero-knowledge proofs. And there was some DevX stuff as well. So here's some more about Leo. So I think the high-level takeaways are that it's the first formally verified language for writing programs that compile to R1CS, which is kind of the stuff of zero-knowledge proofs. It includes a testing framework, package registry, import resolvers, testing, so kind of the traditional stuff you would expect around kind of a developer platform. And it's a functional statically typed language with a look and feel similar to Rust that hopefully means it's a little bit easier for developers to kind of head onboard and learn. So, okay, so what are we going to do today? So I wrote a little application just kind of for fun to show you guys the program. So we're going to do an Oracle Medianizer. So many of you guys probably know what an Oracle is, but it's taking off-chain data and putting it over to the blockchain. Really important for applications like DeFi. Very hard to do in a decentralized way. So one technique that some people have used is this notion of a medianizer, right? And this is what MakerDAO, at least at one point, did, is they took a bunch of reported values and then they took the median of those values and said, hey, this is the real value. So we're going to do that here, and the advantage of using Leo for something like this is that you could construct a system in which the values themselves are inputted are completely private, and then the output is a median, and you just basically you have confidence based on the proof that it works as specified. So I'm just going to take you through here. So I guess all the way through, show you kind of Leo, how you can access it. So we have a landing page, leolang.org. We're kind of going to go there, and yeah, so this is separate from our main site, just FYI, aleo.org, but this is where our programming language stuff lives. So kind of check out the website here. So we have a studio, which I didn't mention on the slides a minute ago, but this is kind of where you can write. One way to write Leo code is to download our studio and write it in our IDE. And we have a playground, an online IDE that I'm going to show you in a minute. But there's also some plugins if you prefer to just run everything on the command line and write in your text editor of choice. You can download some plugins for Leo to get syntax highlighting and some kind of fancy stuff like that. Cool. Okay, so we're going to go ahead and I'm going to kind of walk you through kind of what a Leo program looks like here. Okay, good. This is big enough to see. Okay, so the first thing to note is, this is our online playground, like I said. So it's, first thing is it generates a fancy little name for you, so it basically lets you have a permalink to this, so you can write stuff, come back to it later without worrying that it's going to get deleted. So then you got kind of the run and reset up here, which will compile and run your code. And then you can do, you can preload some things like examples. So we have like a Peterson hash, silly Sudoku, some other stuff. You can download the project, share it around, et cetera. Okay, so let me walk you through like the structure of a Leo program. If you're looking at this, you're like, okay, this is kind of maybe similar to Rust for those of you who are familiar. So every function or every program needs to have a main function, right? In the main function, you got to define exactly the types of variables that it takes as input and that it outputs. Notice that the types it's statically typed, so that's very important, similar to Rust. And then notice that down below here on this lower window, we have an inputs file. And those types need to match the types that are in the main function there. And then, of course, so the types that are in the input file and the registers have to match the output file. OK, so like I said, I'm going to show you this Medianizer. I started trying to type it, but I didn't have enough time to do it in this 10-minute window. So I'm going to preload it, and we're going to walk through the program here. OK, so what are we doing? OK, we're going to take a fixed length array as input, return the median value. We got to take the array of integers. We got to sort the array. And then basically, because we know the length of the array when we input it, we basically just pick the middle index, right? Maybe one kind of wrinkle there is if we get an array of even length, right? We got to average the middle two values. So it's kind of a bonus challenge here that we'll do. So I'll kind of walk you guys through this today, and hopefully you'll get a sense for Leo and what you can do in this paradigm. So OK, so first thing to note is similar to like if anyone's written in C, there's like this concept of like defining your const on top in a .h file. You do the same thing here. So some consts we're going to reference later, you can just define on the top of the file outside of any function. And yeah, so one thing I want to highlight here is really important. I think this is maybe the crux of the difference between writing in Solidity versus writing in something like Leo for zero-knowledge proofs is that all proofs effectively have to be compiled beforehand. And not only the program has to be compiled, but also every basically intermediate step that the program walks through. And so you see, actually I was highlighting some of the array lengths. You can see here when I've got these functions in the declarations, I have this integer value for the array length. And the reason for that is that every function effectively needs to know a priori exactly the length of the input. So there's no concept of like dynamically assigning memory, because again, you got to recall in generating a proof, that proof effectively gets compiled all the way down in all its intermediate steps, and then you can generate proofs from that program representation. So that's just like a little bit of a nuance, and we can, if any of you are interested, I can kind of talk to you after this about some of the stuff that we're working on to make it a little bit easier to abstract some of that complexity away from developers. But that is one thing to note if you're writing in Leo, is you just got to know like, hey, fixed length. So the loops have to be specified beforehand how long they'll run, and then the array that you use, you can't dynamically assign values to. They all need to be pre-specified. OK, so what are we doing here? OK, so we already went through our list of tasks for our demo. So we got our median or our main function. We got our array. I've just kind of picked 10 random numbers here, 10 random integer values. So we got so I've got another function here that finds the median, takes in our array as input. I'm going to find that here. OK, so here's the find median function. So I've got the array as input, and I've got the array kind of as specified. The first thing to note is that, yeah, like I said, I kind of jumped ahead in steps, but I'm just going to predefine the index here. Basically take the middle value, take the middle index from the array I just passed in. And then the next thing I'm going to do, we're just going to go ahead and sort the array. Now, one thing I'm doing here, which is like a little bit different than maybe you would expect, is I'm actually padding the array with zeros. And the reason is, like I said, it has to do with what I just said earlier. The length of the program effectively has to be known in advance. And I want this program to be general and be able to sort an array of potentially variable length. So what I have to do is effectively pad the array up to a certain, my max length of zeros. And then I pass that into a sorting algorithm, which you see here. I have this simple bubble sort implemented. And then basically pass that into the sort. So the array gets sorted with the padded zeros. And then I basically go back in, as the return array comes back to the find median function, and I deserialize it, and I clip off all the zeros that I had in the sorted array. Note this means that I can't pass in any zeros in my array here. Yeah, cool. OK, so now we've clipped down the array. So now we've got our sorted array. Now we've got this logic that is odd. So I implemented a little find whether or not a function is odd, some logic, just a little modulus. And then so we implement that. So then we return the middle value. So OK, so this is pretty vanilla stuff. Here. But I guess the important thing to note is like what happens next. And so now what we're going to do is we're going to actually compile this down to R1CS, and we're going to run it. And oh yeah, just wanted to highlight that the output, if you note the register on the inputs file, that's got to be the same type as what my main function outputs. OK, so we're compiling the program here. And so a couple things are happening. So first, it's compiling from the high-level Leo code down to R1CS. So that's the first step. The setup here, that's effectively the downloading of the public parameters. For all of you, as you know, zero-knowledge proofs, or sorry, ZK snarks require a set of public parameters beforehand. Okay, and the other thing I wanted to highlight here quickly is that we have, like I mentioned in the slides, we have test functionality and some other stuff to make it a little bit easier for devs to have confidence in their code. Okay, cool. Yep, so we have the setup. The setup is basically downloading those public parameters for the snark, and then we have the proof. So the proof generated in about 7,500 milliseconds, so a few seconds, which is pretty fast. I think we should all recall a few years ago proofs in Zcash took like around a minute, and so I think just zero knowledge proof technology in general is advancing at a pace in which stuff like this becomes practical. Okay, so you've got your proof, you can download it. I'm going to kind of show you guys what the output of this looks like. Yep, so you can like I said, you can download, share your project around. So we're just going to take the project here and unzip it. And there's you get your whole kind of directory structure here. So these are the inputs, and I'll just show you. So this perfectly matches what we passed in. Now, like I said, in this example application, these would not be public, right? So this is something that's passed into this function. These are not public inputs, right? This is just private to this program. And then you've got your output file, right? And so if anyone wants to do the math, you can find that, in fact, the median of that array is 7, right? And this would be the public output. So hey, here's a secret array. The median of that array was 7. And then we've got a proof. I won't open the proof because it's binary. It wouldn't really mean much to show. But I think that's kind of cool, right? So we have this effectively this privacy-preserving medianizing oracle, which can power kind of different DeFi applications, and you can kind of do different stuff with. So that's really, in my mind, the power of Aleo is to leverage be able to leverage the power of zero-knowledge proofs without being a PhD in cryptography. And hopefully, languages like Leo and some of our dev tools will help folks do that. Thank you very much. Really appreciate everyone's time, and I hope you enjoy the rest of the conference.
All right, thanks so much, Alex. And next up, we have Cameron from Kong.
Awesome. I think we're good to kick off. I'm Cameron from Kong. This is going to be a little bit of a different kind of demo because our product is actually largely physical. So I'm going to talk a little bit about why we designed it and how we think about the space. This is obviously one of the favorite charts of this cycle. The realization or argument that we've reached 1997 in terms of adoption. But it also means that there's a lot of exciting stuff to come. And one of the big things in crypto in our 1997 version of things is that exchanges are the default way that users interact with their crypto, which ends poorly sometimes. So we thought, what if we could make crypto more like physical cash? Physical cash has a lot of interesting properties to it, and we want people to handle their crypto in sort of a self-sovereign way. So there are some benefits of physical cash, even though it may seem kind of anachronistic. Billions of people know how to use it, regardless of their age. There's no direct transaction costs to digital cash. You can spend it, you can hand it to somebody else. They're instantly final. You don't have to wait for any settlement. You can obviously go out in the world and use it to buy goods and services in most parts. And on top of that, if you lose it or burn it, it's gone, which we think is a really good UX. So in asking this question, how do you make paper crypto? We went back to some early examples. And obviously, you can print a private key in a QR code. But this lacks one key property, which is it's not really transferable. The first person you give it to can easily pull the private key off, and then they can go ahead and spend it. So you can't pass it along. The next one is something like a Trezor or a ledger. And Trezors and ledgers are interesting, but they're really costly and they're really complex. And complexity is actually an enemy here because it creates more attack surface. So if I'm handing a ledger across from person to person, and even if there's a way to store the private key in it, eventually someone might be able to extract that. And the last one is Java card. Java cards are kind of interesting. They're They're effectively what runs behind many credit cards and card-sized devices. They're basically a small computer. The problem is they have large attack surfaces because of their firmware. And so what it really boils down to for physical crypto and crypto cash in general is that the trust is in how you store the keys. You need to store the keys really well, and you need to store them so they're not extractable. And this is our solution to it, which is Concash. Concash is the first instance of a physical crypto cash note. And here's a quick demo showing scanning a Concash note. So every Concash note actually has a secure element on it and NFC front end, and you can actually authenticate against that NFC, and you can challenge it directly to sign a signature. And using that signature, you can verify on chain, and you can see that this Concash is valid. There's also information about the public key, and you yourself can pull that information and say, I don't trust anyone, I want to validate this myself, I want to validate this signature. So again, putting trust in the users. A bit more about the notes themselves. So Concash notes aren't like gift cards. They look and feel like cash. We looked a lot at the psychology of cash notes. And so they're denominated, and that was a really important aspect. They have a time lock. They are not like a gift card where you can instantly pull the crypto off of it. They are, in this case, locked until the end of 2022. And again, gift cards have a very different spending behavior than cash. And they actually store all of the crypto or escrow in a smart contract. So this itself is not a hardware wallet. It's really a signer using the last part of this, which is the specialized secure element chip. And so the smart contract can have all sorts of rules in terms of how you release it. You can release it after a certain point in time. You can release it instantaneously. So really, we're not trying to be specific about that. Broadly, Concash, we realized in the development of it, is sort of a subset of what we're calling a silicon lock contract. And so a silicon lock contract is you have this specialized secure element chip, which can generate key material, does not let that key material be extracted, and it can sign signatures. And then on-chain, you have a contract portion, as noted before. Now, the interesting thing is we started to think beyond cash, there are a lot of other things that this might be applied to. So crypto identity, crypto art, crypto merchandise. But we didn't really explore that when we first launched it at DevCon in 2019. But it was clear that that was just the beginning of things. So some of those things I'll show in just a second here. Of course, the Concash notes themselves, Concash, we talk a little bit about this. But we really use these as a demo. Kong doesn't have any inherent value. But here's one of our first customers that we started to work with who said, hey, we have this unique problem where we have these collectibles and we want to link them directly to an NFT on chain. And Materium has a bunch of actual legal constructs in the real world to do this, but they also wanted to link them physically. Here's a William Shatner collectible that they've integrated a Concash chip into, and you can see right there the chip is actually below a sticker where Bill Shatner himself signed above it. So the owner of this Materium NFT can actually scan the chip and validate, and they can see that it was done. Another project, one of my favorites that we're working with, is MetaFactory. MetaFactory designs merchandise for a lot of crypto-native customers. They've actually integrated the Concash chip into the tag at the back of the shirt. And the really cool thing about that is beyond authentication, the owner of the shirt into perpetuity can get future drops from MetaFactory. So if they have new crypto assets, they now have a horde of super fans who own these shirts, and they can give them new assets. And the interesting thing about this is these shirts are priced well above any typical, even high-end fashion. They're 3 to 4 ETH each. Another product we're working on using the Concash tech is not for the Kong token itself, but for Bitcoin, which was the next obvious step. We think in a lot of parts of the world, a physical Bitcoin would be really interesting, but we had to do a lot working towards the form factor to make it super resilient. So keep an eye out for that. It's called m0.cash. Lastly, the generic form of this silo chip is what we're starting to get out there into the world. And arcs.org is kind of our website where we explain some of that and show some of the awesome customers that we've worked with. So the one instance of a silo I haven't really talked too much about is the Kong passport or the crypto identity card. Again, this is sort of a demo for other projects, and we decided that really to show it off, we were going to build something ourselves. And so that's called Kongland. And Kongland is kind of an experimental digital state with the whole goal of exporting real physical crypto assets. And so in the same way that we have cash and passports, we want to engage with all sorts of DAOs and projects out there who think that a physical component would be really useful to them. So obviously the MetaFactories and Materiums of the world, but also individual artists who maybe they want a physical print of an NFT or they want to make a sculpture. And so the way that we like to say that we're doing this is we're bringing the metaverse into the real world. Obviously the metaverse is a hot topic right now, but we think that eventually it will be around us, sort of infused into all the technology that we use, all sorts of art, clothing, et cetera, et cetera. Kongland as a DAO is trying to use the Kong silo tech that we spent a couple years developing and turning it into a public good so anybody has access to that, because we think that the problem with secure chips are that they're currently closed in their manufacturing process, and we want to open that up. Thus far, we've manufactured 10,000 Kong notes and silos, so we're off to a pretty good start. But we're really excited looking forward in the next year to ship with some new partners. We are in this challenge of dealing with the chip shortage, but luckily we've found some ways to address that. So kind of leaving everybody with a thought around this, which is we're all about self-sovereign crypto and letting people hold their own keys behind their crypto. We think that it's a fantastic UX for the real world and for people to interact with it. And Kongland is the project that's starting that. So just go to Kongland to check it out. I'm Cameron Robertson. I'm one of the creators of it, and happy to answer any questions outside. Awesome. Thank you.
Thanks, Cameron. And next up, we have Roneil from Audius.
All right. Can we start? Awesome. All right. Thank you all for coming by to learn more. I'm Roneil Rumburg. I'm one of the co-founders of a project called Audius. We're a digital streaming service that connects fans directly with artists and exclusive new music. I'll tell you more about it. So a lot of people ask, why does such a thing need to exist? And the place I always begin there is with just an overview of how does the distribution of music actually look today, or the value chain around music look today. You'd be surprised to know that artists actually only capture about 12% of the total $42 billion a year generated in music. The vast majority of value in this ecosystem gets captured by a network of middlemen and intermediaries. Unfortunately, this bubble is covering the corner, but that would say distributor services. So yeah, unfortunately, there is this massive network of middlemen there, and that's what Audius exists to help connect fans directly to artists and to exclusive new music to try to reduce that distance that exists between artists and fans. So what is Audius? It is a digital streaming service, as I said, but the product looks and feels like any other music player that you're probably used to, and I'll get into that in the demo in a minute. But the key here is, I think, the artists, creators, and fans that have come together to cooperatively operate this streaming service for the community's benefit don't need to know anything about crypto to do so. It's pretty awesome, and I think the results around it so far have kind of blown us away as a team. So you can sign up to upload music, you can follow your favorite artists, you can engage with their content, and the way that all of this functions behind the scenes is fully operated by the community that makes it interesting. So things have been pretty good so far. The project launched officially in late 2020. It came out of beta to like a full mainnet launch October of last year. And today we see over 6 million people listen to content on Audius every month. Over 100,000 artists have uploaded content so far. And about 500,000 tracks in the catalog today. So it's been really fun to see just the whole artist music community, especially in dance and hip hop, really rally around Audius as being the path forward for their distribution and their fan relationship management. So yeah, I think the dashboard linked there shows a lot more stats. If you're curious, I'll actually show it in the demo in a sec here as well. But yeah, it's been really great to see. I think that was all right. There we go. So now I'm switching over to the actual product itself. So as I talked about, looks and feels like any other music player that you're probably used to and aware of. You can search for your favorite artists. You can open tracks from them. You can see this track by Skrillex has nearly 250,000 plays on it. He's verified his profile here and is the top track on the network. One thing that's really cool too, you see here, he marked his track as downloadable, and folks can actually download the track, make remixes of it or do whatever they might, upload them tagged that way, and they show up in that page. So yeah, here going through the playlist experience, so you can curate your favorite content. You can share those playlists out with folks. If you build a playlist that gets significant amount of engagement from the network, you can actually earn these rewards from the ecosystem. So you see a lot of folks in the Solana and Ethereum communities have made playlists and curated various things, which has been fun to see what people come up with. 'Cause like everything they do will surprise you. So this is just an example of my profile, or like any profile. You can see content that I've reposted here. You can see content that I've curated into playlists. And then searching for another artist up here, RAC, who's been a big supporter and fan of the network for a while, has one of the bigger profiles on the network. And he actually curated this collectibles page as well, which will come up in a second. So one other really neat thing, because RAC has 34,000 fans following him here who are all Web3 native. Every Audius user has a Ethereum wallet and Solana wallet kind of behind the scenes when they create an account. These are all folks that are Web3 native, whether they know it or not. So this collectibles page has become a sort of storefront that folks are using to curate and show what NFTs they originated that might be purchasable or can be engaged on in some way. So you'll see when we go back, they're tagged as created or owned. So you can own something that you didn't create yourself as well, of course. So yeah, last thing here is, a lot of people ask, well, what's the token do? How does that connect to everything? The Audius token actually is what helps operate the network and support the network. So it has three functions. It secures the operation of all the off-chain nodes that host content, host metadata, which I'll show you in the dashboard in a second. It also grants access to features. So as a creator on Audius, if you stake a sufficient number of those tokens, you can get access to more distribution tools. That's what this tier is that's being shown. So you can actually, by staking using a sufficient number of tokens, get additional value back from the network. There's a little VIP Discord, which has been fun to see folks come engage in. And then the last bit here is governance. So you can, if you stake Audius tokens, you can vote on any and all new features, code changes, et cetera, made to the network. Like us as the original project team that helped get the first version of Audius out the door, can't actually change anything about how how the network operates. So I just switched over to what we call the protocol dashboard. So this is the primary interface to use the token within the network. So as we said, staking and delegation around node operation. There's the governance interface. You can see there are two. I recorded this morning, so there are two active proposals up right now to be voted on. If you open those up, there's a change log. You can see who's able to vote. If you open them up, you can see how they voted before, and then just a little bit of explanation and whatnot. But what's really neat here, kind of in the digging into the analytics a little bit more, all of the data around usage in Audius is being pulled from the nodes on the network. This dashboard's open source. Anyone can go look at how that data is derived. But the dashboard actually is querying the nodes, the community-run nodes on the network to get their slices of usage and then aggregating that together in this view. And then this governance page here just shows you, active proposals. So there's not a whole lot interesting on the governance page itself. There's actually a forum that most of the interesting discussion happens in, which I think I pull up right here. So you can, the workflow here is usually folks in our community go propose things, discuss them, try to convince someone to build them, and then bring them into the governance forum to get them actually, once the code is actually done, that's where you vote it into place. So yeah, I think that about brings us to the end here. So thank you all for taking the time to listen. And yeah, if you have any questions, thoughts, come find me afterwards. I'll be around. And sign up for Audius. That's like the best way to get involved, get engaged. Thank you.
All right, thanks, Roneil. And next and last up for our demos this afternoon is going to be Jonathon Wolff from Streamr.
Hi, can you all hear me? Okay, yeah, good. There we go. Have we started? Yeah, okay, good. Hi, yeah, I'm Jonathon Wolff. I've been an Ethereum dev since like 2017 and working with Streamr since about 2019. I've worked mostly on the smart contract side of Streamr, especially on data unions, which I led, which is sort of like a revenue splitting smart contract, which I'll explain a bit later. It's part of the Streamr stack. But today I'm going to talk more about the Streamr stack generally and its functionality and where we're going and where we've been. So what is Streamr? It's a decentralized infrastructure for real-time data. There's a network of peer-to-peer nodes that are located all over the world, and publishers can broadcast data through this network and reach millions of subscribers. So they don't have to have their own infrastructure. It's a layer to transport this data. And what can you publish? You can pretty much publish anything. Our initial focus was on IoT data. We have libraries to facilitate IoT data, finance data, and like geolocation data. But now we're moving towards audio and video and group chat and things like that. So you can pretty much pump anything to the network. The data is also signed by the publisher. That's an important feature. So that means that obviously you can't forge data through it. And it's also end-to-end encrypted. So we have a marketplace component. So you can buy and sell data streams. And through the marketplace who subscribe to the data streams. And we have a key exchange mechanism so that we can key the data for only the subscribers. And as people leave, we can then kick them out as we rekey. So it's similar to middleware that's available by like Google and Amazon. I've listed some samples over here, but completely decentralized. So initially, Streamr ran the broker nodes, and which are the nodes that actually pass the data around. But now, in our new Brubeck testnet, we've pushed that to the community. So we're encouraging the community to run their own broker nodes and incentivizing them with Datacoin. So in that way, it's completely decentralized, and we're moving towards basically moving all the components to the sort of incentivization where they're monetized and they're incentivized for running these components of Streamr. And we have some usage right now with Pave Motors, which I'll get into later, which is a ride-sharing, bike-sharing around New York City, and also Swash, which is a technology for sharing your browsing data and packaging them into products. So I'll go over this tech stack very quickly. I'm going to go from the bottom to the top. I find that actually clearer. So the broker nodes, as I've explained, are the sort of bread and butter of Streamr's network. They're the plumbing that sends the data back and forth. They're also trackers and light nodes. Those are basically, trackers and storage nodes. The trackers are for config, and the storage nodes are an optional persistence layer, but they're not essential to this talk. And light nodes are Streamr nodes that are like broker nodes that only publish and subscribe, but they don't pass the data all around to different components. So that's kind of the difference between the light nodes and running a full node. We're all built on the Ethereum blockchain. We're mostly on the mainnet. There's a few components that are on the XDAI network, which is like a bridged chain that's quite cheap. But Ethereum is used throughout the Streamr stack, one for identity management. So all users are authenticated by their Ethereum keys, and this includes like signing into the website, signing your data, and things like that. And we also use smart contracts extensively. So our marketplace is all on chain. So you can buy and sell data streams. We also have a core app, which is sort of like a GUI, where you can authenticate with your Ethereum key and do functionality like create data streams, create data unions and products and sell them on the marketplace. And data unions, which is the component that I personally worked on a lot, which is an efficient splitting mechanism. So people can kind of band together, make a product, and sell it on the marketplace. And then as revenue comes in, so as the product is purchased, all the participants are incentivized at once. So it doesn't send individual transactions to pay everyone, but rather has a efficient splitting mechanism so that people can pay for their own withdrawals, and it enables micropayments. And then I'm going to be talking next about the Network Explorer. And the Network Explorer is a new feature with our new Brubeck testnet, where, as I said, we're incentivizing people to run broker nodes and run Streamr components for themselves so that the thing is entirely decentralized. So the next thing I'm about to show in about 8 seconds is the Network Explorer, which you can Google Network Explorer on Streamr and get this demo, and it'll show you the Network Explorer, the nodes that are running. So the first thing right here, we have is an illustration of all the nodes that are running. We've had massive adoption. We launched the Brubeck testnet like 2 weeks ago, and we have already 30,000 participants in it who are being incentivized with Datacoin. And we'll launch the mainnet shortly, but the testnet is doing very well. And this next demo over here allows you to search for a particular stream, and this shows you the topology of the nodes that are serving that stream. So in this case, we have 3,000 active nodes serving this, and you can see that they're decentralized all over the world. So this gives you a graphical picture of where how your stream is actually being distributed. And we also have a metrics section, so each participant in the network identified by their Ethereum key, but they're given kind of a mnemonic so you can identify them. And you can look up performance stats like how much they've earned and throughput and latency and things like that. So just briefly, the data token was ICO'd in 2017. It serves a few different functions within the Streamr framework. One, it's the incentive token for all these different components. So right now we've incentivized broker nodes with Datacoin, but we also plan to incentivize the other components like tracker nodes and storage nodes so that the system is entirely decentralized. It's also the payment token for streams on Streamr Marketplace. So if you sell your data stream on Streamr Marketplace, you're paid in data. But we have integrations with Uniswap, for example, so you can really pay in anything. It'll be converted to data, and the seller will receive payment in data. And then we also have governance through SIP, Streamr Improvement Proposals, where you can vote on various facets of the Streamr ecosystem. For example, allocating funds or things like that for research projects. But we want to make it a kind of community project. At the moment, the voting is not on chain. It's done on snapshot.org. And so Streamr is kind of the agent that enacts the will of the votes. So I'm going to go quickly talk about the tokenomics. So here we have an example where a publisher app, which is a light node, is connecting to a broker node. The broker node is disseminating the data. And you want to incentivize the network to disseminate this data globally. So the broker node posts a bounty, similar to other proof-of-stake systems, that assures that he complies and doesn't delete data, for example. And then he's allowed to receive data and be a part of the broker node, and he earns rewards for disseminating the data properly. And of course, he'd be slashed if he did something wrong, like omitted data and things like that. In addition to running your own broker node, you can delegate your Streamr tokens to broker nodes so that they work for you in a lending arrangement that's similar to other staking systems and other proof-of-stake systems. So in this case, the delegator is lending his data to the broker node to be stake, and both the lender and the broker node are then incentivized, and they both receive rewards as participants in the Streamr network. Yeah, so one of our use cases, we're partnered with Pave, which is a electric bike sharing app based in New York City. It taps into the decentralized network economy with Uber-like features, but without centralized control. And what that means is that you own your own data with Pave. There's a Streamr light node built into all the bikes, and it transmits position data, velocity, and whatever environmental sensors are there. And if you want to monetize them, you can do that yourself through the data union. Data union allows you to pool together, make a data product. So for example, if you wanted to make something like Google Maps for traffic with your own data, you can do that with Streamr, and everyone who participates would be compensated. So it enables splitting of data efficiently, as I said. This is an example right now of the core app. So this is just showing what our website looks like. If you log in with your Ethereum key, you can create streams and data unions, and it's simple. You can also do all this stuff through our API, by the way. The core app is basically just a GUI for the Streamr API. Yeah, so streamers can rent bikes to each other, monetize their own mobility data, connect with infrastructure around them, including other bikes, but also physical infrastructure like traffic lights and things like that. And it's made possible by building on the Streamr network and leveraging its decentralized architecture for data transport. So in addition, all the user metrics are relayed to Streamr's decentralized peer-to-peer app, Streamr, and through the Pave app. So that's all I've prepared for today. Thanks for listening. Our website is streamr.network. And you can easily run a broker node yourself by Googling Streamr, Brubeck, testnet. And the broker node, I should mention, is very lightweight. It doesn't require a lot of processing power. It just requires some bandwidth. And it's a piece of JavaScript you can run. It runs in a Docker container, but you can also run it right in your web browser. So it's really simple, super simple to run a broker node and be incentivized with Datacoin with Brubeck. So thanks for listening.